All right, so on day 2 of this stuff, we got a couple more problems to go through, a couple more things to attack, but realistically we're going to do kind of the same thing. A lot of the stuff that you're going to see today is going to be word problem based, only because we have some formulas to deal with. And like I mentioned to you yesterday with these exponentials, is that this is where a lot of real world problems or real life problems come into play. So just so that you guys know, you're going to see that quite a bit. So, just so that you guys know, what it's going to ask you to do is it's going to say in the year 2000, the world population was about 6.09 billion. During the next 13 years, the population increased by 1.8%. 1.18. I said it wrong. Shocker. Okay? Now it's going to say for part A, write an exponential growth model given the population Y in billions of years after the year 2000. So this is where yesterday I gave you those 2 formulas and I asked you guys to think about which one was growth and which one was decay. Right? So we had Y equals A1 minus R to the T and Y equals A1 plus R to the T. So let me reread this one again and tell me which one of the 2 are we going to use. Are we going to use growth or are we going to use decay? So when it says that the world population was about 6.09 billion, during the next 13 years the world population increased by 1.18%. So we're going to use the bottom one, right? Now, what A stands for, what A is going to be, is it's going to be your initial amount. Okay, so that's what you're going to start with. So like yesterday, when I did that problem yesterday where I messed up on the 8,000 instead of putting 8 in, when it was 25, do you remember the vehicle was worth 25? That doesn't mean it's worth $25 when you bought it. When it said in thousands, it would have been 25,000. Had we put 25,000 in there yesterday, we would have been just fine. So, what number goes in the A is going to be 6.09. 1 plus. Here's where some of you will mess this up, so be very, very careful. When it says 1.18%, you need to move that into the decimal form of that percentage. So you don't put 1.18 in there right now. You got to move it 2 places to the what? Okay. When you move it 2 places to the left, 1, 2, and then when I put that in there, that's really going to be 0.0118 to the T. So what is 1 plus 0.0118? 1.18 to the T. Okay? So there's my formula as far as the population growth model. Now, from here, if I asked you to figure out what was the population in this year, could you do it based on this formula? Yes, you could. So if I said, estimate the world population in 2005, do you put 2005 in for T? No. Remember what number or what year did we start in? 2000. So 2005 is approximately how many years after? 5. So what number are we going to put in for T? 5. So I need a new slide because I'm out of room. So we've got Y equals 6.09, 1.0118, and then we're going to put a 5 in there for it being 5 years from when you start. Okay? This is nothing more than you put it in your calculator and you'll see what it comes up. I would probably round to maybe 2 decimal places. Anybody get it? 6.46 billion, right? Do you need to put all the zeros afterwards? No. You're estimating. That's what it means by estimating anyway, is that you don't have to be exact on that. Okay? What do you think? Not too bad?
Wait, where did we get the 5?
Because it said, in the initial problem, it says, starting in year 2000, this is what the whatever was, estimate the population when it was 2005.
Oh, okay.
So from there, Linz, you started at 2000,
Yeah.
we're figuring out 2005, that's a 5-year gap.
Mm-hmm.
So if it would have said in the year 2025, we would have put 25 in there,
Okay.
okay? Everybody okay with that? So, word problem, not too bad though, was it? What if it would have said the population decreased?
Do the top problem?
Then I do the other one where it's 1 minus the percentage. Do I do the process when I plug the number in the same though?
Yes.
Yes. Okay. Then part B for that is going to say estimate the year when the population was 7 billion. So that means 7 billion is going to be on this side. Now, like I mentioned yesterday with these, right now, by hand, you don't know how to do this by hand yet. Okay, that's coming later on in the chapter where we're going to go through this, whatever, but this is identical to the problems yesterday and the one that I had to help you with this morning on 22 because of me not reading the problem right yesterday. So for this particular thing, like what Keely did with the calculator earlier for me, for that one, you could put 7 in for y1. You could put this in for y2. Do not forget the whole problem. Okay? And find where they intersect. To use the intersect feature on your calculator, once you type one into y1 and the other into y2, you hit second trace. Then that list of options comes up. Remember we did minimum, we did maximum off of there. We found zeros before. Intersect is option 5. You hit option 5 and then it will ask you, is this the first curve you're on? Yes or no? Yes. Hit enter. And then it'll go to the second curve. Is it on the second curve? Yes or no? Yes. Hit enter. Will you or may you have to change the window?
Yes.
Yeah. Okay, here's something else I asked or answered for somebody yesterday was, how do I get my window back to the original?
Zoom 6.
Zoom 6 is the one, and that was in 4th hour. I had somebody ask me that question, and we had to talk about it again, just to remind everybody. In order to get the problem back to the original window, hit Zoom 6. Okay? By the way, did anybody get the answer? 11.9?
Yeah.
Or 12 if you round to the nearest year. As long as you're in the right vicinity, I'm going to give you the answer.
Wait, I got 1.25.
I got the same.
You got plus.
What? I got the same thing.
Huh?
Oh, that's
Didn't I get the same thing?
You get 11 point.
Yeah.
Yeah. They rounded it to 0.9. Lindsay, did you figure it out?
Yeah, I
Parker
forgot
help you?
the 0.
Okay. That might make a difference.
I will know.
Okay. All right. Everybody okay with problems like that? It'll be 2 parts. That's what it'll be. Now, this next part is going to look something like this. It's going to say the amount Y in grams of a radioactive isotope chromium-51 remaining after T days is Y equals a 0.5 T over 28, where A is the initial amount in grams. What percent of the chromium decays each day?
So this is a fractional.
Oh yeah. When we're referring to decay things, remember I talked about yesterday when I talked about people that would use this, and I specifically said carbon.
Does it ever actually read from 0?
No, it never actually gets down to 0. You keep cutting things in half, it's never going to take a piece of paper and rip it in half, 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 and rip it in half. It gets really tiny, but it never actually goes away. So here's how you got to treat this. Okay, we're nothing more than finding R, but if you think R is 0.5, you're going to not be right. Okay? I want you to focus on this part up here. That's the part that I want you to focus on. Do you see how it says T over 28? I am going to rewrite that. Okay, I'm going to rewrite that as 1/28 times T. Okay, when the T is on the top like that, I'm going to break it out into two different parts. I'm going to break it out as 1/28 and the letter T. Okay, so I've got two different things. All I did was I took the top and separated it from the bottom. Is everybody okay with that? Now, here's where your calculators are going to come into play for me. What needs to happen is when you have a base raised to an exponent, and in this case 2 exponents, you could do one of them at a time if you'd like, which is what I'd like you to do. What's 0.5 raised to the 1/28th power? Now, when you type this in, it's 0.5 caret parentheses 1 divided by 28, close it. If you don't put parentheses around the 1/28th, especially on some of your older calculators, you're not going to get the right answer. On your newer ones where there's a shadow box around that exponent, you shouldn't have to need the parentheses. Okay? So, what number comes out? 0.9755. Okay? Now, do you remember what we talked about at the beginning of today, where we talked about how much above or below 1% or 100 it would be? Right? Is this above or below?
Below.
How'd you know it was below?
It's less than 1.
It's less than 1. How much less than 1 is it?
0.1.
What's 1 minus 0.9755? 0.0245. And if I made that into a percent, how much percent would that be? 2.45%. On the one question that you're going to have that looks like this, this is what you would do. Split the exponent into two different pieces, raise whatever's in the parentheses to that power, and then identify is it above or below the percent, above 1. And if it is, how much above or below it is it? Okay? Are you guys okay with that one? Then the last questions that you guys are going to have are going to require you to use this formula. A equals P, parentheses, 1 plus R to the over N to the T. Now, it might look like a big formula or whatnot, but for those of you who have savings accounts, by show of hands, how many of you guys have a savings account? Like almost all of you. Okay? Then this formula gets used for you. This is how they calculate interest on your savings accounts. Okay? What A stands for is the amount in the account. P stands for your principal, which is not Dr. Martin or Mr. Johnson or Dr. Fall. Okay? The principal is the amount of money that you start with. Okay? So if I said, upon graduation, Madison got $2,000 and put it in a savings account, that would be $2,000 would be my P. Okay? R,
Initial amount you put into the account.
right, and that's you never touching it ever again. Meaning you can't put any more into it or any more take out of it. Okay? You're not putting any more into it. You're taking $2,000 and saying, I'm sticking this away and saving it for later. Okay? The R, I know it's kind of hard to read on the screen, but the R stands for the rate. That's the interest rate that the bank is going to give you. For example, one of my savings accounts, I have 2 of them. One of my savings accounts is 0.25%. So when I put my number in for mine, I put in 0.0025. Okay? Those will be in percentage formats. The N stands for the number of times in a year. There's 2 places for N. So some of the more frequent ones that we've had. We have annually. Anybody know what the word annually means? Yearly meaning one time. What about monthly?
Just what it says.
12.
Once a month or 12, because there's 12 times in a year. Anybody know how many times quarterly is done?
4 times a year.
4 times. Okay? Every 3 months, the interest is done. My savings accounts that I have 2 of them. One at First Western that gives me 12, and the other one that gives me at Gate City quarterly. So I've got 2 different ones set up, but they each give me different times in a year. Okay, semi-annually be how many times?
2 times.
Twice, every 6 months. Those are the most common ones, besides daily, which would be how many times?
360.
365. Good job. Then T stands for time in years. So for instance, if they say after 6 months, you don't put 6 in there, you put in 0.5. How would I get 0.5 out of that?
Because it's half.
It's half a year. Good. Okay? So here's what they're going to have you do. Well, let's use Madison for example again. So Madison got $2,000 from her grandma for graduation and decided to put that money into a savings account for her retirement down the road. So her principal is $2,000. In a bank or a savings and loan place that offers 2% interest. So the rate is 2%. And by the way, if you get 2% interest on something, please let me know. I'd like to make more money than my 0.25%. Okay? Compounded quarterly. So it'll say the word quarterly in there. When Madison retires 40 years from now, how much money will be in the account? So how much is my time? 40 years. Right. So let's put all the stuff in. A is what we're trying to find. What's the P? 2,000. 1 plus. When you put the R in there, do you put 2 in there? What do you put in there? 0.02. You got to move it over 2 spaces. Where's the decimal place at now if it's 2%? After it, 1, 2. 1 spot, so 1 0 in front of it. Okay? Divided by, how many times is quarterly being done? 4. Good. Raised to the 4 times, how many years are we going? 40. Okay. Now, my calculator data crunchers, it's time to type it in. If you don't want to type it in all at one time, can you do a technique called chunking? Can you do them at different times together? Absolutely. All right? So what I've done in the past, for me anyway, sometimes I've done it like this. I've taken 0.02 divided by 4. That's the first thing in the order of operations I should be doing. I get an answer. Then I add 1, because that's inside the grouping symbols. I get an answer. Then I raise it to the 4 times 40, which is 160 times. I get an answer, because I'm doing exponents. And then I times it by 2,000, and what answer comes out?
4,442.22.
And 22 cents?
Yeah.
So that means Madison started out with $2,000. Now she's got $4,442. $42.22 without ever having to touch the account. Now, is it a lot of money? No, it's not. But at the same time, she didn't do anything to do it. She didn't do anything more to it. She didn't keep adding in regular payments into that account. She just took a one-time deal and put it in there, and that's it. Okay? If we're putting regular payments into something, that's more of an annuity thing, and we'll do that later. This is something that it's just a one-time deal, and then you just let the interest work. Okay? What do you think? How this is going to change? Instead of quarterly, it might say monthly, or daily, or the years would change, or the interest would change, but the process is all the same. Are you guys comfortable with this?
Yeah.
All right. Again, like I mentioned, they're all going to be word problems today, okay, because of the fact that that's all we kind of talked about. So on page 300, 301, 23, 27, 37, 39. Do you want more?
No.